Okay, everything below, if it contains all of the properties of the stuff above. So because we're going upward to get to a rectangle from a square is always a rectangle. Okay, there's no downward or upward path to get from a rectangle to a trapezoid, so this is never. And actually, if you think about it, a rectangle always has opposite sides that are parallel to each other. And the definition of a trapezoid is that it has exactly one pair of sides that are parallel to each other. These sides cannot be parallel. If they were, it would not be a trapezoid. So this is never. Okay, a rhombus is a square. To get from a rhombus to a square, we go downward. And because we're going downward, this is a sometimes. A trapezoid is isosceles. Well, we're going downward, so some trapezoids are isosceles. So this is a sometimes. The diagonals of a kite are perpendicular. Well, that's one of the properties of it, so they have to be. So that's always. The diagonals of a rectangle bisect opposite angles. Well, that's not necessarily true in a rectangle, but it is true in a square. And to get from a rectangle to a square, we go down. And when you're going down, this is a sometimes. In other words, this is true for some rectangles. It's only true when the rectangles are actually a square, though. Opposite angles of a parallelogram are supplementary. Well, that's generally not true because this and this clearly do not add up to 180. But if they were both right angles, they would. And therefore, a rectangle, opposite angles are supplementary. So to get from a parallel to a rectangle, we go downward. So because we're going down, this is always true. Sometimes true. Okay, the diagonals of a rhombus are congruent. Well, this is generally not true. This is not the same length as this. But it is true for a square. Those diagonals are congruent. And therefore, if we go down from a rhombus to a square, going down tells us that it's a sometimes. This is true for rhombuses that are squares. But remember, not most rhombuses are not squares, but some are. Okay, both pairs of opposite sides are congruent. Let's just go through this one at a time. For a parallelogram, that's one of the properties, that both pairs of opposite sides, that's this right here, are congruent. So it's true for a parallelogram. It's obviously true for a rectangle because a rectangle is below the parallelogram. This has all the properties of that, so we don't even have to check these properties. We know it's true for this. Same for a rhombus. This is going downward, so we know that's true for a rhombus as well. And same for a square, because we're going downward still. But then the trapezoid, it says both pairs are congruent. Well, one pair would be congruent for an isosceles triangle, but not both pairs. So it's not true for this, and it's not true for a kite, because those are your opposite sides. Okay, all sides are equilateral. Well, the first place that we see that is right here, where all sides, you can see it's not. But this is true, so then this is also true. So this is true for a rhombus and a square. Okay, diagonals bisect each other. Let's go through this one at a time. For a parallelogram, this and this and this and this are the same. So these diagonals bisect each other. So that's true. Let's look at so if we know it's true for a parallelogram, we know it's true for a rectangle, we know it's true for a rhombus, and we know it's true for a square. So I can just select those without thinking too much about it. Now let's look at a trapezoid. This clearly does not bisect each other, right? It's not going to do that here either. And then let's look at a kite. While this diagonal has been bisected, this hasn't. So they haven't bisected each other. They're both not bisected. So that's not true for a kite either. So it's true for those four. All the angles are congruent, meaning equiangular. Well, we can clearly see that's not true for these. It's not true for this, but it is true for this because they're all 90 degrees. For all of them, for them to be the same, they have to be 90 degrees because for them to be the same, they have to be all, 4 times 90 would be 360. So this is true and this is true. This is only true for a rectangle and a square. Exactly one pair of opposite sides are parallel. That's true. That's a definition of a trapezoid. So it's true for this and this, but the only choice here is this. Okay, for A, because we know this is a parallelogram, opposite sides are congruent. So A is 15. Opposite sides are congruent. In a parallelogram, we also know that the diagonals bisect each other. So if this is 11, B has also got to be 11. Okay, if this is a parallelogram, this is a transversal. So this and this are alternate interior angles. So X is 40. Okay, for Y, this and this makes a transversal. So this and this are alternate interior angles. So this is 25. And then here we have a triangle. Those add up to 180. So Y plus 25 plus 40 equals 180. So Y must be 115. Okay, if this is a parallelogram, then diagonals bisect each other, so this is equal to this. So we have 3x minus 9 is equal to 2x plus 7. I'll bring this way, so x is equal to, I'll bring that way, and I get 16. Okay, if this is 58, and I know in a rectangle these are parallel, so this is also 58 because these are alternated interior angles. And this is 90, so x plus 58 must be equal to 90, so x must be equal to 32. The median is equal to the bases added up divided by 2. I could either multiply each side by 2 or I could divide on the right, which I'll do because it's even. So 32 is equal to 2x plus 22. I could have also left this alone and multiplied to get 64 here. You get the same answer. Bring this over by subtracting. So x is equal to 5. In an isosceles trapezoid, these are congruent, so those are equal to each other. I'll bring the 5x over by subtracting it and get 7x. I'll bring this over by adding it, and 14 plus 28 is 32, 42. So x is equal to 6. In a square, this times root 2 is equal to 6. So x times root 2 is equal to 6. That means x is equal to 6 divided by root 2, which is 3 root 2. Okay, this is a 45, 45, 90 triangle. So x is equal to 10 times root 2. That's simple. Here, x squared plus 6 squared is equal to 9 squared. So x squared is equal to 75, 45. So x is equal to the square root of 45, which is 9 times 5. We square root that, and we get 3 root 5. This is a 30, 60, 90 triangle. So the short side times root 3 is equal to the long side. So x is equal to 5 root 3. Okay, I'm going to call this y. And then I know that y is equal to 6 root 2, that's this, times root 2, which is 6 times 2 or 12. So this is equal to 12. Now this is a 30, 60, 90 triangle, so I'm going to call this side z. And I know that z times root 3 is equal to that 12. So z is equal to 12 divided by root 3, which is 4 root 3. Oops, what am I talking about? This is the hypotenuse here. So this z is half of that 12. So let me redo that. Sorry about that. So z is equal to y over 2, which is equal to 12 over 2, which is 6. And then x, the long side is the short side times root 3. So x is equal to z root 3, which is 6 root 3. Sorry about that. If this is 5, this has got to be 5. And then you see we have one of the most famous Pythagorean triplets. This is a 5, 12, 13 triangle. So this right here is the 13 side. So I can say that x is equal to 13 right off the bat. But if you don't remember that, then you have to use Pythagorean's theorem. And that says that 5 squared plus 12 squared is equal to x squared. So x is equal to the square root of 169. So x is 13. Either way you do it would have been fine. Okay, here we have a triangle, and I'll call this side y. So then we have 8 squared plus y squared is equal to 17 squared. So 64 plus y squared is equal to 289. And then I'll bring this over. So 289 minus 64 is 225. So y is the square root of 225. So y is 15. And then on this side of the triangle, these are the legs and this is the hypotenuse. So x squared plus 9 squared equals this squared, and we just figured out that this is 15. So that's 15 squared. So that means that x squared is equal to 225 minus 81, which is 144. So x is the square root of 144. So x is equal to 12. Okay, if both of these are 60s, then this is an isosceles triangle. And an isosceles triangle, these two sides are the same. These two things are the same. So I'll call this side thing y here. And if this is isosceles, then this is also x here. Okay. Now, in an isosceles triangle, we have a 30, 60, 90. Well, this is a 30, 60, 90 triangle. So this times this times root 3 is this. So y must be equal to 9. That's because in a 30, 60, 90, the small side times root 3 is the long side. And the hypotenuse is twice the short side. So x is equal to 2 times 9, or 18. Okay, here we have x squared plus 15 squared equals 21 squared. So x squared plus 225 is equal to, this is 441. So that means x squared is equal to, I'll subtract this. Oops, this is 441. And 441 minus 225 is 216. So x is the square root of 216. And 216 is 6 times 36. And you could have done a factor tree to get to that. But anyway, I'll square root this and I'll get 6. So x is equal to 6 root 6. Okay, first thing I'm going to do is I'm going to find this side right here, and I'll call it y. And you notice I have a 3, 4, 5 triangle. So I know this is a 4. I don't have to do any math there. Y is equal to 4. But if you didn't see that, you could have said that 3 squared plus y squared is equal to 5 squared. So 9 plus y squared equals 25. So y squared equals 16. So y equals 4. But again, if you saw that this was a 3, 4, 5 triangle, you could have jumped to that. Okay. Now, if this is 4 and this entire thing is 6, that makes this 2. And then what I have here is a triangle, and I have 2 squared plus 3 squared equals x squared. So x is equal to the square root of 13. First, mentally check that you have a triangle. This 2 smaller sides added up really is bigger than this. So then I'm going to take the longest side and square it and see how that compares to the sum of the squares of the 2 smaller sides. 22 squared is 484. 18 squared is 324. 21 squared is 441. Well, this is obviously less than, which means that this is an acute triangle. Before we do the work, I'm going to mentally check that this is a triangle. So the sum of the 2 smaller sides is 13. That's less than this. It has to be bigger than this. So this is not a triangle. Okay, so we're going to take the difference, 15 minus 9. That's as small as it could be. So I'll say that's less than x. And then it's going to be 15 plus 9 is the largest it could be. Well, this reduces to 15 minus 9 is 6. And that adds up to 24. So the sides have to be between 6 and 24. Well, if the angles are congruent, that means they're equal. So I'm going to start by setting those equal to each other. I'll bring the 4x over by subtracting it and get 8 minus 4 is 4. I'll bring this over by adding it. 12 plus 24 is 36. And I'll divide each side by 4, and I'll get x is equal to 9. Then 4x plus 12 is one of the sides. So 4 times 9 plus 12 is 36 plus 12, which is 48. So I know one of the angles is 48. The adjacent side is 180. They're supplementary. So 180 minus 48 is equal to 132. So the other side is 132. And then because this is isosceles, we have another 48 and another 132. I guess I could have listed them differently, but those are the 4 angles. Okay, a square has a perimeter of 28. If all 4 sides are equal, that means each side is 7. And then this is the diagonal. We don't know what it is, but that's an isosceles right triangle. So this, you could do the math, or you know that this is root 2 times that. So x is 7 root 2. Or I shouldn't say x, because there is no x in this problem. It's just asking for the diagonal, which is 7 root 2. Okay, the first thing I'm going to do is plot these points. So pause the video and take a moment to plot those points. Okay, so those are the 4 points. And now I want to prove that ABC is a parallelogram that's showing that both pairs of opposite sides are parallel. So I want to show that these 2 sides are parallel. So I'm going to do the slope of slopes. Let's do the slope of AD. Here's A and here's D. So it's y2 minus y1, 4 minus 1 over 6 minus 2, which is 3 over 4. And then the slope of the opposite side, BC, is 1 minus negative 2 over 10 minus 6, which is 3 over 4. So these have the same slope. So I show that by doing this. Okay, now I need to see that these slopes are parallel. So the slope, let's do AB first. So the slope of AB is negative 2 minus 1 over 6 minus 2, which is negative 3 over 4. And the slope of the opposite side of AB is CD, is 4 minus 1 over 6 minus 10, which is 3 over negative 4. and negative 3 over 4 and 3 over negative 4 are the same thing. So those are parallel, and I'm going to show that by doing this. And then I'm going to write my conclusion, and then I'm going to say both pairs of opposite sides are congruent. Therefore, ABCD is a parallelogram. That's it. Okay, take a moment to plot these points and pause the video to do that. Okay, and I forgot to label these. So negative 2, 8 is C, and then negative 6, negative 6 is A, and T. Okay, now the first thing we're going to do is we're going to graph the median of CD. So it's coming from C, it's got to go to the opposite side, and we got to know the midpoint of this. So the first thing I got to do is find the midpoint of AT. So I'm going to put it in midpoint form already. So the X values are the sum of the X's, so 6 plus negative 10 over 2, and the Y values are negative 6 plus negative 4 over 2, which is equal to negative 4 over 2 and negative 10 over 2, which is equal to negative 2 and negative 5. So there's our midpoint. So at negative 2, negative 5, I'm going to draw a dot. And then from C, I'm going to draw a line to that dot. And then I'm going to draw this little line here and this little line here, showing that these are equidistant, and that's a midpoint. And I forgot to label my point. That's point D, because this is CD. So there's C, that must be D. Okay, the altitude AE. So here's A, and I've got to hit this side at a right angle. So it's got to be perpendicular. So the first thing I need to know is the slope of this line. So I'm going to find the slope of CT. So the slope is going to be the difference of the y's, negative 4 minus 8, over the difference of the x's, negative 10 minus a negative 2. So this is negative 12 over negative 10 plus 2, which is negative 8. So this reduces, by dividing by negative 4, I get a 3 over a 2. So I know the line perpendicular to that is the opposite reciprocal, which is negative 2/3. Now remember, we're starting at A. So from this point, I know it's going to go to this. So I'm going to hit, instead of, I'll write this like this. Instead of writing it as a negative 2 over 3, I'm going to write it as a 2 over negative 3. So I'm going to rise 2 and run backward 3. So rise 2, run 1, 2, 3, and there's my point right there. I just lost it. 1, 2, 3, there it is. Okay, I'll draw a couple of them so it's easier for me to draw this. So rise 2, run 1, 2, 3, rise 2, run 1, 2, 3, rise 2, run 1, 2, 3, something like that. And I am going to, did I do this right? Rise 2, run 2, 3, 2, 1, 2, 3, yeah. Okay. All right, there it is. Oh God, it's hard to draw on this screen. And then I need to show that this is a right angle by doing that. And I need to call this point E, because this is AE. Let me make that a little smaller. Okay. Okay, finally, the perpendicular bisector of CA. So the first thing I got to do is I got to know the midpoint of this. So I'm going to do the midpoint of CA. And that's going to be, here's my C and here's my A. So negative 2 plus 6 over 2. And 8 and negative 6 over 2, which is 4 over 2 and 2 over 2, which is 2 and 1. So my midpoint is 2, 1, which is right there. Okay, now I need to know the slope of CA. So the slope of CA is the difference of the y's, so negative 6 minus 8, over the difference of the x's, which is 6 minus negative 2. So that's negative 14 over 6 plus 2 is 8. So this is negative 7 over 4. So the opposite reciprocal, the perpendicular, is positive 4 over 7. I hope you can see that. I'm having trouble seeing that. But anyways, 4 over 7. So starting from this point, I'm going C, the perpendicular of CA. So starting from this point, I'm going to rise 4, 1, 2, 3, 4, and I'm going to run 7. 1, 2, 3, 4, 5, 6, 7. And there's my point. Might be easier to do one on the other side as well. So I'm going to go down 4, 1, 2, 3, 4, and I'm going to go 1, 2, 3, 4, 5, 6, 7, and I'll put a point there. So now I'm going to grab a ruler, and I'll put an arrow on either side of it, and I'll make markings like this. I have to do 2. I can't do 1 because I already used 1. So I'll do 2. That shows that that's the midpoint. And then I have to also do this to show that it's perpendicular. And that's it.